Okay, so here's a topic that I think is one of the trickier ones for let's do tomorrow. Doing on tonight's homework due tomorrow, and it's called finding isoelectronic atoms. And now I think we're going to really find that the use of good notation is really important. Okay, so I've gone to some trouble here. I know this is over the top. I know it is, but believe me, it's worth it. So I'm going to some trouble here to write out this notation. None of these are going to have multiple atoms. So this little n in this corner over here, that's the number of atoms present in the structure. They're all going to be 1, so we don't have anything there. But this is just a general notation, which I think is useful in this kind of problem. So let's get straight to the problem, and we'll see what I mean by that. Actually, before I do, let's look at these numbers. M is the mass number. That's in the top right-hand corner right here. We're not going to be dealing with any mass numbers here, but if there were a number there, that would be the mass number. That's the number of protons plus the number of neutrons. Okay, that's not the average atomic mass. It's the mass number. Z is the atomic number. We usually don't write that because usually when we're writing symbols, we just say something like helium. And we know if it's helium that this number is really 2, right? So that's redundant. And so you probably don't recognize that Z being down in that corner there, but we're going to use it some. And charge, of course, you do recognize, because if you had something like sodium, you would say plus, and that number up there in the top corner is the charge, right? All right, so let's go back to the problem. Finding isoelectronic atoms. So we're here being asked to find 3 different atoms or atomic cations. All right. So I'm going to come here and say, well, I'm looking for 3, and we're looking for 3 atoms or atomic cations. So I'm going to say, let's go with atom 1. That's the atom. Here's the first cation, and here's the second cation. And I'm just going with the simplest ones I can think of. And they have 12 electrons each. Okay. All right. So if the atom has 12 electrons, it must also be 12 protons. How do you spell 12? Okay, so I'm going to put a 12 right here. All right. Now, if this structure over here has 1 more proton than it does electrons, it's got 12 electrons, it must have 13 protons. Okay, and this is going to be 14. This is great. This is awesome. So now what I'm going to do is I'm going to look at my periodic table, which is not showing up here at the side. I know that. Let's go over here. It's not there. All right, but normally we've got a periodic table over here at the side, and we know that 12 is, we're going to look that up, and we're going to find that 12, where's my blue marker now, is magnesium. That's not blue. Come on. Magnesium is 12, right? Okay, and we don't put anything there if there's a charge of 0. Okay, so what's the thing on the other side of magnesium? I need to look at my periodic table because I don't see it there. Bad planning. Bad planning. I need a periodic table, and it's going to be in this book here. And if it's 13, then it's going to be aluminum. Okay, man, I wonder if you guys knew that. I didn't know that. It's aluminum. It's got a +1 charge on it. And then 14 is going to be silicon. All right. And there I have it. Okay, so going stepwise and taking the notes here makes it possible for me to invest very little energy, or risk, I should say, in solving this problem. Okay, aluminum, superscript plus, and silicon, superscript 2 plus. All right, so let's check that and make sure we're right, and then we'll do, our little parade. Okay, great. Okay, so I hope that's helpful. Let me encourage you to consider making out notes and going stepwise, and thereby making this